Hi, in this video, we are going to start looking at the theory for straight lines. In the previous videos, we have already finished all the other chapters in coordinate geometry. So I want to do a revision video for straight lines and pair of straight lines. Right, so we start off with uh, the basic idea of the standard straight line equation. And the standard equation that we look at is y is equal to mx plus c. Here, x and y represents the coordinates of a point on the line. M is the slope of the line, and C becomes your y-intercept. And by y-intercept, I mean the point where the line intersects the y-axis. So obviously you can see that if you put x is equal to 0, you get y is equal to C. So 0 comma C is a point on this line. And here M is the slope of the line, and M is basically tan theta, where theta is the angle that the line makes with the positive x-axis. The line makes with the positive x-axis. We will see other forms of the line equation as well, but for now, let's think about what we know from this equation. So from here, we can say that if you want to find out the angle between two straight lines, with slopes m1 and m2, that angle can be given by the formula tan theta is equal to mod of m2 minus m1 by 1 plus m1 m2. How does this come? You can just simply draw a diagram, and let's say these are my two lines. This has slope m1 and this has slope m2. And the angle between them is this small angle. You can see here, this is the point P. This angle is what we need. But we know already that this is tan theta 2. Basically, this is angle theta 2. And this angle is theta 1, where m1 is tan theta 1 and m2 is tan theta 2, right? Now, automatically, we can see that this angle is theta 1 by vertically opposite angles. And you can say that theta 2 is equal to this angle theta plus theta 1. So therefore, you're getting theta is equal to theta 2 minus theta 1. How did I get this result? I got it by looking at the triangle here and saying that theta 2 is the exterior angle and it will be equal to the sum of the two interior opposite angles. So this is coming, and now you take tan on both sides, you get tan theta is equal to tan of theta 2 minus theta 1. And expanding according to the trigonometric formula, this is equal to tan theta 2 minus tan theta 1 by 1 plus tan theta 2 into tan theta 1, which will give you this formula, right? So that is the angle between two straight lines. Now, if two straight lines are parallel, then their slopes will be m1 is equal to m2. The slopes will be same. And if two straight lines are perpendicular, then m1 m2 product should be equal to -1. The reason is that the angle between straight lines is m2 minus m1 by 1 plus m1 m2. And for perpendicular straight lines, this angle is 90. And tan 90 is infinity. So 1 plus m1 m2 should be 0, right? So these are the things that we come to know from the basic y is equal to mx plus c equation, right? Also, if you have 2 points on a line, how do you calculate the slope? So if the point is x1 comma y1 and another point is x2 comma y2, the slope is obvious. It is y2 minus y1 by x2 minus x1, right? So that is how you find the slope. So that was my first equation of a line. Now let's look at other forms of the line equation. So one is the point slope form, where you know a point P x1, y1, and you know the slope m. The equation of the line will be y minus y1 is m times x minus x1. The other form is the two-point form. In this case, the equation would be, if you know 2 points P and Q, the equation will be y minus y1 is equal to m, but m you can write in terms of these 2 points. So it will be y2 minus y1 by x2 minus x1 into x minus x1. Then the other form is the standard form, which is ax plus by plus c is equal to 0. This is a linear equation in x and y, and this is also the straight line equation, because you can rewrite it like this: by is equal to minus ax plus minus ax minus c, and from here we can write it as y is equal to minus ax by b minus c by b. So now it looks like the y is equal to mx plus c form again, right? So from here, comparing these two equations, you should be able to say that the slope of the line here is minus a over b. That is something that you'll be needing a lot. Whenever you have a linear equation in this form, the slope of the line equation is simply minus a by b. Then the next form is known as the intercept form. Intercept form of the line equation. And that looks like this: x by a plus y by b equals 1. Here, a is my x-intercept and b is my y-intercept. What do I mean by intercept? Intercepts are the points where the line cuts the x and y axis. So if this is the line equation, this is the point a comma 0, and this is the point 0 comma b. This distance is your y-intercept, and this distance is your x-intercept, right? And obviously, you know that 2 points a comma 0 and 0 comma b lie on this line. And that is your intercept form of the line equation, right? Okay, then we have the next form of the line equation that we want to look at is the fifth form, which is basically the normal form. Normal form of the line equation. So here we have a line. The information that is given to you is that the perpendicular from the origin to the line has length p and is making angle alpha, right? So we want the equation of the line L, and we are given this information that the perpendicular from the origin to the line has length p and makes an angle alpha with the positive x-axis. In this case, what we can see from here, this figure, is that this length is p. So what is this length? You can easily look at this right angle triangle and figure out that if this length is a, you can say that a by p, or actually we can write it as cos alpha. Cos alpha is clearly p by a, right? So therefore, a is equal to p by cos alpha. And if this length is b, you can say that this angle is 90 minus alpha. And you can do cos of 90 minus alpha is equal to p by b. So b is equal to p by sine alpha, because this is sine alpha. So we know the distances a and b, and you can see that these are the intercepts, x-intercept and the y-intercept. So using intercept form, x by a, which is x by p by cos alpha, plus y by b, which is y by p by sine alpha, is equal to 1. That gives us x cos alpha plus y sine alpha is equal to p. And that becomes the line equation in the normal form. Here, you know the length of the normal p from the origin to the line, and you also know the angle that the normal makes with the positive x-axis. So then you get this line equation, right? Another form that is super important is known as the parametric form. Parametric form of the line. So let's say you have a line like this, and there is a point P, x1, y1 on this line, right? And there is another general point x comma y on this line. And this line makes an angle alpha with the x-axis. This direction is positive x-axis. and alpha is the angle that the line makes with the positive x-axis. And let's say the distance between the 2 points, let's call it P dash and P is R, right? So automatically in this figure, if you know R and alpha, you can express x and y in terms of x1, y1, because we can drop a perpendicular like this and we can say that this distance is x minus x1 and this distance is y minus y1, and that is obviously r cos alpha and r sin alpha. X minus x1 is r cos alpha and y minus y1 is r sin alpha. So the equation of the line is written like this: x minus x1 by cos alpha is equal to y minus y1 by sin alpha is equal to r. But that is not the most important thing here. The most important thing here is to represent this point in terms of x1, y1 and r and alpha. x1, y1 is a known point on your line. So now we can write from here x is equal to r cos alpha plus x1 and y is equal to r sine alpha plus y1. So that becomes the general idea for the parametric form of the line equation, right? Okay. Then one thing that I have to mention is, suppose you have a line equation ax plus by plus c is equal to 0. What is the equation of a line parallel to this? Equation of a line parallel to this. We know that the slope will be same. So the new equation should also be ax plus by so that the slopes remain same. But it can be plus k is equal to 0, where k is a constant different from c, right? And similarly, equation of a line perpendicular to this line would be bx minus ay plus p equals 0. And p is another constant. Why am I putting bx minus ay? Because right now the slope of this line is minus b by minus a, which is b by a, whereas the slope of my original line was minus a by b. So you can see that minus a by b and b by a, when you multiply, you get minus 1. So definitely these two lines are perpendicular to each other. So given a line equation, writing a line which is parallel or perpendicular to it is pretty easy. And we have just seen how to do that, right? Okay. Now, the next point that we need to understand is the perpendicular distance. Perpendicular distance from a point P x1, y1 to the line ax plus by plus c equals 0, right? So what we need to do here is actually find the length of the perpendicular from P x1, y1 to this line ax plus by plus c equals 0. The formula for this comes out to be this: ax1 plus by1 plus c mod of divided by root over a square plus b square. That is the length of the perpendicular. And how would you figure out this perpendicular line equation, right? The idea is you have to shift your origin to the point P, which is x1 comma y1. Why are we doing that? If you shift your origin to the point P, you can think of this line. This becomes your new origin. So this is the length of the perpendicular from the origin to the line, right? So what you have to get is the new equation of the line. New equation of the line after shifting the origin. After shifting the origin. So how do I do that? So let's think about it. Let's say this was my original line, ax plus by plus c equals 0. And let's say P was a point here. P was x1 comma y1, right? The origin was originally here, O, right? Which is 0, 0, right? Now, what I want to do is I want to shift my origin to this point, right? I want to shift my origin to this point. Let's call it O dash, right? And I want the equation of the line in my new coordinates. This is my y dash and x dash, right? So in order to shift the origin, let's say capital X and capital Y are the new coordinates of the same point of the point x comma y. Point x comma y. So if there was a point x comma y on this line, this was measured with respect to the old origin, and now the same point is measured with the new origin, which is capital X and capital Y. You should realize that you can write a relation x is equal to capital X plus x1 and y is equal to capital Y plus y1. Why? So capital Y was this height and small y was this height because it was referred to the old origin, and capital Y is this height, right? Capital Y. And this much is y1, right? So you can easily say that small y is equal to capital Y plus y1. Similarly, you can do this also. So now in the old equation, think about it. What will the old equation become now? You will write it like this: K A capital X plus x1 plus B capital Y plus y1 plus C equals 0. So the equation is becoming A capital X plus B capital Y plus AX1 plus BY1 plus C equals 0, right? This is my equation. Now, if you think about it, this equation can be written like this: AX plus BY is equal to minus of AX1 plus BY1 plus C, right? And if you divide both sides by root over a square plus b square, root over a square plus b square both sides, then you get this situation, right? And now you can see that this equation looks like the x cos alpha plus y sin alpha is equal to p equation. This was the normal form equation of the straight line, right? Here, the p was the distance from the origin to the line. And right now my origin is here. So I will be able to find this distance p by just comparing this equation with this equation, right? And you can see that why did I divide by root over a square plus b square both sides? Because I wanted to make it cos alpha and sin alpha. Cos alpha and sin alpha is not guaranteed if you have just a and b, because a and b could be greater than 1. So I divided that to basically normalize it to less than 1 quantities. And now I can write this side as x cos alpha, y sin alpha. So this should be my perpendicular distance. And modulus of that will be my p here. And that it comes out to be the formula that we wanted to prove. Mod of ax1 plus by1 plus c by root over a square plus b square becomes the perpendicular distance from the point x1 y1 to the line ax plus by plus c, right? Similarly, you can also find the distance between any two parallel lines. Two parallel lines. Let's say one line is ax plus by plus c1 equals 0, and the other line is ax plus by plus c2 equals 0. The distance between the parallel lines is mod of c2 minus c1 by root over a square plus b square. Again, the proof is similar. You can actually just shift, or you can actually take the distance from the origin to both of the parallel lines and subtract that distance, right? So that will also help you find this formula. Okay. The next idea is how to find the point of intersection of two lines. Point of intersection of two non-parallel lines. Non-parallel lines. So obviously it is pretty simple. If you have two lines like this, one line is this, one line is this, all you have to do here is solve the two equations. Solve the two equations to find the relevant intersection point. To find the point of intersection. You should not try to remember, obviously, the formula for this. It is simple linear equations. You have to solve the two equations to find the point, right? Okay. Then the next thing is what are concurrent lines? Concurrent lines. So basically the idea is if three or more lines have a common point, three or more lines have a common point of intersection, then they are called concurrent lines. And the common point of intersection of the three lines is known as the point of concurrency, right? Now, you can prove that following point lines are concurrent. The medians of a triangle are concurrent. You can also prove the same thing for altitudes of a triangle. They are also concurrent. Similarly, angle bisectors of a triangle are also concurrent, and also perpendicular bisectors of the sides. Perpendicular bisectors of the sides of a triangle are also concurrent. And the point of concurrency in each case is going to be centroid. These have names: centroid, orthocenter, incenter, and circumcenter. Now, the detailed theory for and the properties of these you must have done in your properties of triangle chapter in trigonometry. So I will not go into too much detail. However, you should always be able to figure out this stuff. Suppose you have A, B, and C. What you can do is, if I want to prove that the medians are concurrent, I need to make a line from A to the midpoint of B and C, which is D. So if I know B and C and I know the vertex A, then I can always find a line equation AD, right? Find the midpoint of B and C and find the two-point form line equation AD. Similarly, find the midpoint of A and C, which is E, and find the line equation BE. So AD and BE equations, if you find, then you should find the point of intersection of these two. Point of intersection of AD and BE. That should be the point G. And what you need to prove is that the median CF also passes through G. So what is CF? F is the midpoint of A and B. And you find the line equation CF. Find the line equation CF, and you can show that G also lies on CF. And if you can show that, then you have proved that the three medians are concurrent. So similar strategies are used to prove the other results as well. That perpendicular bisectors are congruent, angle bisectors are congruent, and so on, are concurrent, and so on, right? So this is not very difficult. You just have to use your basic understanding of what these 4 points are. And if you know how to do that, then you'll be able to find all of these points in a triangle. Don't try to remember the results for orthocenter, circumcenter, incenter, the location of those. If you have been given those results, you should try to not remember them. You need to know the basic properties and you need to be able to find it yourself. Memorization won't help you here. So we will do questions where we'll discuss questions involving these points. For now, I don't think it is super important. The next thing that I want to talk about is basically the idea that when can we say that two lines a1x plus a b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0. What can we say when we look at these two equations? these lines are parallel. These lines will be called parallel if their slopes are equal. So you will have the condition that A1 by A2 will be equal to B1 by B2. That will come from slopes being equal, right? But the lines are identical. Lines are identical if all the three ratios of coefficients are same. Lines are identical if and only if you can say A1 by A2 is equal to B1 by B2 is equal to C1 by C2. So then they represent the same straight line because the coefficients are in the same ratio. Here, you have to say that A1 by A2 is equal to B1 by B2, but not equal to C1 by C2. In this case, the ratio of the coefficients of x and y are similar or are equal. However, that is not the ratio of the constant terms. Because if the constant terms are also in the same ratio, then the lines are identical. So you need to know that. Then the next point that I wanted to cover was the idea of foot of the perpendicular. Foot of the perpendicular from point x1, y1 to the line ax plus by plus c equals 0. So what I want to find here is basically the location of this point h comma k, which is the foot of the perpendicular from a, which is x1, y1. So like this, to the line ax plus by plus c equals 0, right? Okay. So how do I find that? So the idea here is this: since P lies on the line, so the coordinates h comma k will satisfy the line equation. So you'll have AH plus BK plus C equals 0. That is the first relation. And also the slope of AP times slope of the line, the product should be -1. So what is the slope of AP? It is k minus y1 by h minus x1, and the slope of the line is minus a by b, should be equal to -1. So from here we are getting k minus y1 by b is equal to h minus x1 by a. This is the relation that we get from the slopes, right? Now, because of this condition, we can always write by ratio and proportion properties, we can write h minus x1 by a is equal to k minus y1 by b is equal to a times h minus x1 plus b times k minus y1 by a square plus b square. How am I getting this? So basically, a times h minus x1 by a square is the same as h minus x1 by a. And we also know that kb times k minus y1 by b square is the same as k minus y1 by b. And when two of the ratios are equal, we have h minus x1 is equal to this, is equal to this, and is equal to this. So we can add the numerators of the ratio. So basically I'm using the property x by y is equal to p by q, means x plus p by y plus q is also in the same ratio. You can prove this. So here I'm just adding the numerators a into h minus x1 plus b into k minus y1 by a square plus b square, the denominators, right? Why is this important right now? Because now we'll be able to prove this. So we have h minus x1 by a is equal to k minus y1 by b is equal to a into h minus x1 plus b into k minus y1 by a square plus b square. That is the result here. And let's simplify this stuff. AH plus BK minus AX1 minus BY1 by a square plus b square. And notice in the beginning we had said that the point h comma k lies on the line. So AH plus BK plus C is 0. So AH plus BK was equal to minus C. So this stuff can be written as minus C minus AX1 minus BY1 by A square plus B square, right? So finally, we have this result H minus X1 by A is equal to K minus Y1 by B is equal to negative of AX1 plus BY1 plus C by A square plus B square. And this is the result that you need to remember. Why do you need to remember it? Because this will directly give you the location of H and K. If you know the point P x1 y1 and the line equation ax plus by plus c is equal to 0, all you need to do is write this relationship, right? We have done the proof of how this relationship has come. It comes from the fact that the point the point or foot of the perpendicular lies on the straight line, and also the slopes are product of the slopes is -1, and then we are doing some ratio and proportion properties to get this. Now x1 is known here, a is known, y1 is known, b is known, and the whole thing on this side ax1 plus by1 plus c by a square plus b square is completely known. So therefore you should be able to find h and k from here. So please try and remember this. This is super important and you'll be using it many times. Foot of the perpendicular from a point to a line. How to find that, right? Okay. The next thing that I want to talk about is image of a point in a straight line. So basically here, the straight line equation is given, and you have a point again here, x1 comma y1. But now you have to not find foot of the perpendicular, you have to find the reflection here, the Q point, right? Q is the reflection of the point in the straight line. So this is h comma k. Now my job is to find this h comma k. Again, this is perpendicular and this distance is equal to this distance. You can call this as R. So basically PR is equal to QR because the line acts as my mirror. Line is the plane mirror and this is the image of P in the line. Line equation is AX plus BY plus C is equal to 0. Using a similar proof like before, basically we will be able to do the same thing again. So again, I have two equations. First of all, I know slope of PQ and slope of the line product will be -1. So I can say k minus y1 by h minus x1 times minus a by b will be equal to -1. That is the first result. And the second result is that the midpoint of P and Q, which is x1 plus h by 2, comma k plus y1 by 2, this lies on the line. Therefore, I have a times x1 plus h by 2 plus b times y1 plus k by 2 plus c is equal to 0. So I have ax1 plus by1 is coming out to be negative 2c minus ah minus bk. Or you can say again ah plus bk is equal to negative 2c minus ax1 minus by1. Right? This is what is coming from here, right? So use this result and this result, and using both of them, I can write things like h minus x1 by a is equal to k minus y1 by b, and then use the same ratio and proportion property. So h minus x1 by a is equal to k minus y1 by b is equal to a times h minus x1 by a square is also equal to b times k minus y1 by b square. So it will be equal to a times h minus x1 plus b times k minus y1 by a square plus b square, right? So therefore I can write h minus x1 by a is equal to k minus y1 by b is equal to ah plus bk minus ax1 minus by1 by a square plus b square, right? And this time ah plus bk will be minus ax1 minus by1 plus 2c. And there is already a minus ax1 minus by1. Actually, I made a mistake. This was minus 2c, not plus 2c. You should check that again. We have this is minus 2c. So you get this by a square plus b square. And finally, I get the result that I wanted to show, which is h minus x1 by a is equal to k minus y1 by b is equal to minus 2 times ax1 plus by1 plus c by a square plus b square. This equation gives us the image hk of the point P x1 y1. So x1 y1 is the point, hk is the final image, and you can calculate it if you know the location of the point and the equation of the straight line. Notice the difference between this equation and foot of the perpendicular equation. The only difference is now image has a ratio of 2 here. In foot of the perpendicular, you didn't have this 2, right? So that is what you need to do here. And these 2 points are super important. So you should try and remember what we did here, because you will be using this several times. So that's about it for the standard straight line theory. Now what we will do is we'll think about what are pair of straight lines. Okay. So pair of straight lines. So if you take two line equations, L1 is A1x plus B1y plus C1 equals 0. And another equation A2x plus B2y plus C2 is equal to 0. The product of these two, L1, L2 equal to 0, is the equation of the pair of straight lines. Of a pair of straight lines. Okay? So in pair of straight lines equation, you should see that when you multiply this, you will end up with a general equation like this. You will end up with a general equation that we have seen many times before in conic sections as well. This becomes my general equation, and the condition that this is a pair of straight lines is that you are able to factorize this 2-degree quadratic in x and y in terms of two linear equations, right? Because after multiplying these two only we were getting this, right? So the condition that it factorizes into two linear equation is that del is 0, and del is basically abc plus 2fgh minus af square minus bg square minus ch square. If that is 0, then you will be able to factorize this equation into two separate straight lines, right? The proof for this is straightforward but slightly long. It is there in SL The idea is express this equation as a quadratic in just x or just y. And once you are able to express this equation as a quadratic, you have to analyze the discriminant of that quadratic. In order for it to be factorizing properly, the discriminant should be a perfect square. And if you write the condition that the discriminant of the quadratic in x is a perfect square, you will end up with this condition. So I have done that before on my channel. You can check it out in older videos on the channel. However, you can also look at SL and see the theory. It's a straightforward proof, which I will not get into right now. Right? So this general equation of 2-degree, if del is 0, it represents a pair of straight lines. And in general, the pair of straight lines will be like this, general straight lines, right? However, we have a special case. If we have a situation where you have the equation ax square plus 2hxy plus by square is equal to 0, and basically there is no term with x or y or constant term, right? In that case, you should understand that this equation is a homogeneous equation in x and y. Homogeneous equation in x and y. What do I mean by homogeneous? Homogeneous equation means that every term has the same degree. This is a degree 2 term because the power of x is 2. This is also a degree 2 term because there are two terms x and y. Both of them have power 1 and 1. So the total power of the variables is still 2. And this is also a degree 2 because it is degree 2 in y. We are missing the terms 2gx, 2fy, and c, right? These are linear term, and constant term. Degree 1, and 0. So whenever you have a situation where you have a homogeneous equation in x and y, that will represent two straight lines passing through the origin. Passing through the origin. How? Because when you have a line through the origin, that will be of the form y is equal to m1x. Another line will be y is equal to m2x. So the product of y is minus m1x and y minus m2x. Notice that when you do the product of these, you will not end up getting any degree 1 or degree 0 terms. All the terms that you get will be degree 2, and that's why the equation looks like this, right? So now we can easily see from here that if ax square plus 2hxy plus by square equals 0 represents a pair of straight lines, then the sum of the slopes of the lines is equal to minus of 2h by b, and the product of the slopes is equal to a by b. How do I know that? Because I am comparing it with y minus m1x into y minus m2x. If you multiply these two, you will get y square minus m1 plus m2 xy plus m1 m2 x square equals 0. And since this represents the same lines as this, we are going to write it like this: by square plus 2hxy plus ax square is 0. And both the equations are supposed to represent the same lines. So you can do 1 by b is equal to minus m1 plus m2 by 2h and is equal to m1 plus m2, m1 m2 by a square. So we can easily see from here m1 m2 is equal to not a square, we have a just. m1 m2 is coming out to be a over b, and we have m1 plus m2 is coming out to be minus 2h by b, right? So basically, looking at the line equations, we can deduce the product of the slopes and the sum of the slopes of the two lines, right? And because we know the product of the slopes and the sum of the slopes, now I can find the angle between the two lines also. Because tan theta would be m1 minus m2 by 1 plus m1 m2. So if you try to do this, this will be equal to root over m1 plus m2 whole square minus 4 m1 m2 divided by 1 plus m1 m2, right? So this will become what? m1 plus m2 is minus 2h by b. So 4h square by b square minus 4 times a by b, because product of the slopes is a by b, divided by 1 plus a by b. So the top part is becoming root over 4h squares minus 4ab by b, and the denominator is a plus b by b. So you are getting 2 times root over h square minus ab by a plus b. And that becomes the angle between the two straight lines. So if my pair of straight lines equation was this, I can look at the coefficients and figure out the angle between the two straight lines. And that formula is 2 times root over h square minus ab by a plus b. So that also tells us when will the lines be parallel and when will the lines be perpendicular, right? So if I have this situation, ax square plus 2hxy plus by square is equal to 0, the angle between the lines is tan theta is 2 times root over h square minus ab by a plus b. If tan theta is 0 or h square is equal to ab, then the lines are parallel. Why are they parallel? Because actually the lines are not even parallel, they are identical straight lines. Both the straight lines are same because you will end up with a situation where ax square plus 2h square is ab. So this is root ab xy plus by square is 0. And this can be written as root ax plus root by whole square is equal to 0. So both the lines are actually the same line, root ax plus root by equals 0, right? If tan theta is equal to pi by 2 or 90 degree, so the angle between the straight lines is supposed to be 90 degree, then you can see that from here it follows that a plus b must be 0, right? So the equation of pair of straight lines will represent two perpendicular lines if the equation looks like this: ax square plus 2hxy minus ay square equals 0. Notice here that the b coefficient is minus a. In that case, this homogeneous equation represents two perpendicular straight lines, right? Okay. Then the next idea is a generalization of the same theory that we have done. The equation of pair of straight lines passing through x naught, y naught, passing through x naught, y naught, and parallel to the lines ax square plus 2hxy plus by square equals 0 is what? So notice here that this represents two straight lines through the origin, and we need to make, like, let's say these are the two straight lines through the origin, L1, L2. I want the equation of straight lines that pass through x naught, y naught, but they should be parallel to L1 and L2, right? L3 and L4. So what I know is that the slope of L3 should be same as slope of L1 and slope of L2 should be same as slope of L4. So the relation of the slopes here, M1, M2 is equal to A by B and M1 plus M2 is equal to minus 2H by B. Those relations should still be valid here, right? So the equation should still look the same, the only difference being that the origin has been shifted to x naught, y naught. So the equation in this case, you should understand, is going to be a times x minus x naught whole square plus 2h times x minus x naught y minus y naught plus b times y minus y naught whole square equals 0, right? So that will be the equation of the pair of straight lines passing through x naught, y naught and making the same or being parallel to the lines represented by ax square plus 2hxy plus by square is 0, right? Okay. Now, the next thing that we want to look at is the equation of the lines bisecting the angle between two given lines. So let's say we have one line ax1 plus a1x plus b1y plus c1 equal to 0 and another line a2x plus b2y plus c2 equal to 0. The equation of the angle bisectors will be given by this result. You can write it like this: a1x plus b1y plus c1 by root over a1 square plus b1 square is equal to plus or minus a2x plus b2y plus c2 by root over a2 square plus b2 square. Now, why is this happening? Why is the equation of the bisector being given by this equation? First of all, why are there two equations? We'll get two equations here because there is a plus and minus, right? In the plus case, you get one bisector. In the minus case, you get another. Why are there two bisectors? Because whenever you are given two lines, you can bisect the acute angle between them or you can bisect the obtuse angle between them. This is my required line 1, line 2. You have this angle alpha and this angle pi minus alpha. So bisector 1 is this and bisector 2 is this, right? And I want to represent both the bisector equations, and that's why I get plus or minus here. Also, you should know that ultimately the two bisectors will be perpendicular to each other, right? Because you are bisecting this angle, so this much part would be angle pi by 2 minus alpha by 2, and this much would be alpha by 2. So the angle between the two bisectors is always 90 degrees, right? Also, how do I know that this equation represents the bisector? So that is based on a simple property. If you have a bisector, angle bisector, let's say this and this angles are equal, alpha by 2 and alpha by 2, right? Then any point lying here, x comma y, will be making equal length perpendiculars, or perpendiculars here will be equal. PR is equal to PS. Why? The reason is that if you look at these two triangles are definitely congruent. The reason they are congruent is you have angles, two angles are definitely same, so it is already similar, and one side is common. Common side means the ratio of similarity is 1:1, which means the triangles will be congruent by SSS congruency. And because these two triangles are congruent, PR must be equal to PS. And how do I write the condition that PR is equal to PS? If line 1 and line 2 equations are given by A1x plus B1y plus C1 equals 0 and A2x plus B2y plus C2 equals 0, what is the distance PR? PR distance is mod of A1x plus B1y plus C1 by root over A1 square plus B1 square. And PS distance is simply mod of A2x plus B2y plus C2 divided by root over A2 square plus B2 square. So basically, when we write PR is equal to PS, we are automatically getting, if you remove the mod, you will get plus or minus sign, and you will get the equation that we earlier wrote for the bisectors, right? So the bisector equation is coming by simple geometrical fact that the angle bisector is equidistant from the two straight lines, right? So you're getting this equation of bisectors. Now, in several books, you have these random results about how to remember which is the obtuse angle bisector and which is the acute angle bisector. You should never try to remember those results. There will be many things or many theories that will be given to find out which one is acute angle bisector and all. Whether it is the plus sign or the minus sign and all. Don't try to remember it. If you have line equation like this and you have written the bisector equations like this, a1x plus b1y plus c1 by root over a1 square plus b1 square is equal to plus minus a2x plus b2y plus c2 by root over a2 square plus b2 square. Suppose you have written the bisector equations. Now take one of the equations, take one of the equations. By one of the equations, what I mean is take either the positive sign or negative sign. Suppose for now I take the positive sign equation, right? Simplify that line equation, get the line equation, and then find the angle between this line, B1, let's say, or whatever line B1 you got. B1 is A1x plus B1y plus C1 by root over A1 square plus B1 square is equal to A2x plus B2y plus C2 by root over A2 square plus B2 square, right? This equation, find the angle between this equation and the line L1 or L2, right? So basically, you're trying to find the angle between the line and the bisector. If that angle alpha is less than 45, then automatically what we know is the overall angle would be less than 90 and that bisector would be the acute angle bisector. If that angle comes out to be greater than 45 degree, then the bisector with the plus sign was the obtuse angle bisector. So you don't need to remember any condition. It is basic common sense. Pick any of the bisector equations, get the angle between that bisector and the line. And if that angle is less than 45, that bisector that you chose was acute. And if it is bigger than 45 degree angle, then that was the obtuse angle bisector, right? Finally, what we can also say that we can write the combined equation of the pair of bisectors. If you basically you have to take the plus sign and the minus sign, and both the equations, if you multiply together, finally you will get the equation of the pair of bisectors of the two straight lines. So if I have my normal straight line equation like this, ax square plus 2hxy plus by square is equal to 0, then the equation of its pair of bisectors will come out to be x square minus y square by a minus b is equal to xy by h. Now, I will leave that to you. You should be able to prove this. First, basically, write these equations as y minus m1x times y minus m2x, and then try to do the bisectors of this and this, these two lines, L1 and L2. When you get the bisector equations, multiply the two bisector equations and prove that this is the final equation that comes for the pair of bisectors. Notice that the coefficients of x square and y square are 1 and minus 1, which was the condition that they are perpendicular lines. The two pair of bisectors are perpendicular to each other. So therefore, we are getting the coefficients coming out to be 1 and minus 1. Okay. Then the next idea and the last thing that I wanted to cover here is the idea of homogenization. So homogenization is a simple idea, and it is based on the theory of pair of straight lines only. So suppose you have a curve like this and you have origin here and you have a straight line like this. This is line L and this is curve C. And the line L is cutting the curve in 2 points B and A, right? Homogenization is basically trying to find the equation of the pair of straight lines OB and OA. And you want to try to find the equation of line pair OB times OA equals 0 without actually solving and finding points A and B. Finding points A and B. See, if the line equation is given, line equation is Lx plus My plus N equals 0. And the curve equation was ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equals 0. Technically, if somebody told you that you have to find the point of intersection of the line with the curve, it will be an annoying problem to solve, because this is a very general equation. If you have to solve it with a linear term, it will not be easy. You will have to substitute for y minus lx minus n by m, and it will still become annoying. It will be a big quadratic, right? Solving it for a and b will be difficult. However, finding the equation of the line pair OA and OB is not at all difficult. We don't need to find A and B, right? Because we know the theory that any line pair through the origin has an equation of the form ax square plus 2hxy plus by square equals 0. Or basically, the equation of a line pair through the origin is always homogeneous in x and y, right? So it will never have a degree 1 term or a degree 0 term. It will always have only degree 2 terms, right? So what we do here in homogenization is use the equation of the line and use the equation of the curve to come up with a homogeneous 2-degree equation. And if you can come up with a 2-degree homogeneous equation in x and y only using this line and this curve, that equation is going to be the equation of your line pair, right? So what we will do here is simply take the 2-degree terms, keep it as it is, and multiply these terms with appropriate stuff to make it 2-degree. So how do I do that? So first of all, I notice that Lx plus My plus n is equal to 0. So we can write Lx plus My is equal to minus n, and Lx plus My by minus n is equal to 1, right? And then I will look at the curve equation, and everywhere where there is a 1-degree term, I will multiply it with this quantity, which is degree 1 itself, and make it a 2-degree term. So I'll say 2gx plus 2fy, and I'll multiply both of them with lx plus my by minus n. And the constant term is c, so I have to multiply it with square of this in order to make it degree 2, right? Notice that this value is 1, so we have not changed the equation. Similarly, this value is also 1, so we have still with the same curve equation. But now we are making the curve equation and transforming it in such a way that the resultant equation from here will always be homogeneous in 2-degree. And this resultant homogeneous 2-degree equation is the equation of the line pair OA and OB. And you can use all the properties that we have learned about pair of straight lines now from this final equation of the line pair OA and OB, right? So again, we will do some problems on this topic. We will try and do some practice problems on the whole of straight lines next. So straight lines and circles, you can expect a couple of videos at least doing more problems on it. But theoretically, what we have covered in this last hour or so is more than enough for your JEE. So you don't need to remember anything more. What we have covered is enough. So please go through the straight lines and circle videos as well. I will do a couple of problem solving videos to revise all of the concepts, but whatever we have done so far, you don't need to remember anything more. So please keep that in mind. We will be solving all the problems that we'll see using the theory that we have discussed today. Right? So I hope you learned something from this video, and if you like the content, please subscribe to the channel, share it with your friends. Also, a happy Diwali to everyone who watches the video today. So that's it for now. I will see you next time.